guys, welcome back to another Newtonian gravitation problem. A 573 kilogram satellite orbits Earth with a speed of 4.3 kilometers per second at a distance of 2.4 times 10 to the 7 meters from Earth's center. A. Calculate the acceleration of the satellite, and B. Calculate the gravitational force on the satellite. So first things first, to find the acceleration, this is acceleration due to gravity. So the acceleration due to that massive host planet, which in this case is the Earth. Okay, so for part A, to find the acceleration, if you haven't seen where the expression for g comes from, please check out videos 143 and 144, specifically the beginning of video 144, where I show you where this expression comes from. But essentially, g is equal to acceleration due to gravity is equal to the gravitational constant times the mass of the host planet divided by the distance between the center of this planet and the object you're considering squared. Okay, so the acceleration, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared times mass of the host planet. The mass of the Earth is 5.98 times 10 to the 24 kilograms divided by the distance between their centers squared. Okay, so in this case, if we were wondering about the acceleration due to gravity on the surface of the Earth, we would plug in the radius of the Earth here, 6.38 times 10 to the 6 meters, and then square it. In this case, we want to know how the acceleration changes when you're actually this far from the Earth's center. So r is actually 2.4 times 10 to the 7 meters, and don't forget to square that. So when you punch all those in your calculator, you are going to get g is equal to 0.69 meters per second squared. That is the magnitude of the acceleration of the satellite. Now for part B, calculate the gravitational force on the satellite. So this part is actually even more straightforward. Okay, so for part B, force of gravity on the satellite, you can use the gravitational expression g me ms over r squared, the universal gravitational equation. Another way to do it would simply be to say, you know what, I already know the value of g at this location. So why don't I just do this? Fg is equal to mg. What's the mass of the satellite? It's 573 kilograms, right? 573 times g at that location, 0.69 meter per second squared. So, okay, in case you guys missed it, now I'm just doing Fg is equal to mg because I have the new g at the new location. If you do 573 times 0.69, you're going to get 395.37, or about 396 newtons, which is the same result you're going to get if you calculate it using this, except it's going to take you a lot longer. So this is why they had us calculate g in part A. So that's it for this video, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned tomorrow at 12 noon for video 146, Newtonian Gravitation 4. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always, guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways, guys, Physics in the Flesh out. Woo-hoo! Holy crap, my nose looks big on camera.